Thank you. So yes, I am Eric. I'm a senior consultant with AgileAssets. I've been here for quite a while. I'm going to start off by giving a brief history about what I've been doing here. So I wanted to try something new. I'm going to tell you two truths about myself and one lie. You've all heard about that. All right, so let's get started. I'm a Spartan, so I graduated from Michigan State University. I know if there's anyone from Ohio here, sorry. But other than that, you guys can probably respect that. I think most everyone I've dealt with is out of the Big Ten, so we're good there. When I graduated with a dual engineering degree, mechanical and civil engineering. And finally, I don't drink alcohol. All right, so I want to give you a briefing on my project history. I've been around for a while. I started the company in 2008. So the first project I went to was Wyoming. I did my training in Austin, Texas. So after about 6 weeks on site or living there, I shipped out. So February 17th of 2008, I drove in to Cheyenne, Wyoming in the middle of the night in the middle of a blizzard. Welcome, you know. So that was fantastic. It took me a while to find the hotel, to get out of my car, and then it took me probably just as long to walk to the front door. But in any case, I was there for about a year and a half. It was fantastic. Moved down to Oklahoma, and I was introduced to a whole nother world. They have ice storms. So for 2 consecutive winters, I went through, I believe it was a 100-year storm, right? So 16 inches of snow hit during the first winter, the first major storm. And I'm thinking, this is Oklahoma, what the heck's going on? I go out and I try to dig out my truck. I have 1.5 inches solid thick of ice on my truck. Took me an hour and a half to dig that out. So welcome to Oklahoma. So after that, 2.5 years in Oklahoma, and then I went to West Virginia. Well, West Virginia taught me a little something called, and I have to look this one up because it's a little difficult, methylcyclohexane methanol. You guys heard about that? It's MCHM for short. So in January, I believe it was January 9th of 2014, there was a chemical leak in the water supply. So that affected about 300,000 people, residents in West Virginia. So I'd been there for a while, so it wasn't like welcome, but it was quite an interesting situation that happened there. So then finally after that, I go to Minnesota. And let me tell you what Minnesotans think. They think that's warm. So this is towards the end of January when I saw this on TV, and I said I have to have that. So I don't want to leave anyone with a bad taste of these states. So let me give you something positive to run with. Wyoming by far has the nicest people I've ever met. Not to diss anyone else, there's nice people in every state, but Wyoming's definitely got the cake there. Oklahoma has got the best food that I've ever had. Now granted, I haven't spent long enough in Texas, but what I can say is when Texas says they have the best barbecue, and then Oklahoma says they have the best barbecue, I don't care, I like barbecue. So then in West Virginia, they have the absolutely most beautiful mountainsides, scenery. So you go through there, I can drive for an hour and I can just stare out there as long as there's no one else on the road because they can kind of drive like crazy. But it's definitely one of the best places to just get a great look and see what's going on around there. And of course, there's Minnesota. They have a lot of great things. They have probably the best public services in any state that I've ever seen or even researched. But they also have, I went backwards. They also have a lot of lakes. So it's the land of 10,000 lakes for anyone that knows that. I actually took this definition straight out of there. There's 11,842 lakes that are defined 10 acres or larger. I know a lot of people are going to say there's 13,000 some lakes, but definition of a lake. It's also the land of 10,000 playgrounds, as my son is quickly learning. So with that said, today I'm here to talk about the signals and lighting inspection process that we've got set up in AgileAssets. The quick agenda we got here is I'm going to go through not a brief introduction of myself, I already covered that one, but I'm going to talk about the introduction to the inspection process. Then we'll talk about how we're doing the setup in our system. Then we'll get into the actual process of how the details are getting filled out. We'll take a quick look at how the results get compiled and how that data is going to be available to us. And then, pending time, we'll see where we're at that point, but we can give a quick live demo on the subject. I really hope you guys have a lot of questions because I don't want to dive into the system. So with that said, let's go ahead and let's start talking about the inspection process. So as owners of traffic assets, we are going to be responsible for the function of these assets. We're going to be responsible for the operation of these assets, and we're going to be responsible for the structural integrity of these assets. What that really means is the function, we want to make sure that that asset, the signal or the lighting system that we're dealing with, that actually serves the purpose it was intended to serve. Operation, you want to make sure it actually works. And with the structural integrity, you want to make sure that it's not going to fall down and kill somebody. So up here I put down a quick blueprint. You'll see there is some significant effort that goes into the design of a lighting system. This is actually a signal system, but it's not easy. It's pretty complex. So next, as owners of these traffic assets, we are responsible to ensure the performance of these assets, make sure they keep working as time goes on. We want to maintain the safety of the consumers of the road network. And then by doing all this, we're actually going to be optimizing the network. Because you know if you grant safety, it actually makes everything work out a little bit better in the long run. So at this point, what I want to do is I want to give you a quick definition of what I'm going to be calling or referring to as a signal system. For this implementation, I'm showing one signal system right down here. It is essentially an intersection. We have 4 assemblies, one here, well, 2 here, and 1 here. I should have probably taken a better look at that picture. But we got a number of signal pole assemblies to go with this signal system. I'm going to give you an example later, so it'll all make sense at that point. So the question, why are we inspecting these things? Well, we want to make sure that we can do a proactive detection of any infrastructure flaws that exist. We want to make sure that the consumers of our network, the drivers, they are safe. But we also need to be aware of any potential weather effects, freeze thaw. Oh, I'm kind of skipping ahead. But any weather effects. And then there's also the idea of legal support. And why does legal support make sense? 'Cause sometimes these things don't stay in the air. And if you notice right there, they're pretty big. That thing could do some damage to somebody. All right. So with respect to detrimental factors, I was saying weather effects earlier. You do have freeze thaw. Minnesota, where I'm at right now, if you remember what was on the board yesterday morning, they do have a very broad range of temperatures from, it said -15, but I swear it's a lot lower than that. It's got to be -25 when I was there. Below -30, up to the hundreds. So as you can see, I mean, that you all know that has an effect on your assets. But also there are major storms. Hurricanes on the East Coast do a lot of damage out there. You have earthquakes in Oklahoma that can do a lot of damage down there. Depending on where you're at, you're going to have a whole variety of environmental factors that may affect you. Then there are also the unnatural factors. A car accident. Someone hits a pole, it could fall down, it could stay up. Either way, an accident had happened. You need to be able to go ahead and see what the asset looks like after that. There's also vandalism that you may need to be worried about. And then, of course, more importantly and more known, the life cycle factors. Your assets are typically built with an understanding of this is how long they're going to last. And then fatigue kind of comes into play with a number of different things. It could come in with windstorms. Every asset that has something hanging out, like the signals, they're load-bearing assets. So you have to understand that that's going to create some fatigue. And also the wind shears are going to create fatigue in the other direction. So all those things may play a factor. And it's all taken account for in the design. Of course, I didn't dive into the design very well. So the next idea is when am I going to be inspecting my assets? There's actually 4 standards of protocol for doing these structural inspections on your signals or your lighting assets. You have the initial inspection. So once the asset gets installed, about 60 days or so after the inspection, you want to go through and make sure everything's still working out. All the bolts are tightened, everything's operating to design, maybe the foundation, you want to make sure that's properly set, that kind of stuff. After that, you can do routine inspections, which they call visual inspections or ground inspections. That's just to assess it and make sure that it's all looking good and working accordingly. It's a less detailed inspection, which you can see from the next one, which is the in-depth inspection. And that's when you actually get in there and you do a lot of the checking the boxes and making sure all the elements are in a proper order. And that's the kind of stuff that we're going to be going over today, is the in-depth inspection stuff. And then, again, going back to when you have accidents and stuff like that, you may need to do interim inspections. If you do an inspection and you find out that something's a little deficit, you may want to do some work and then come back and do another inspection. Make sure that the work that was done actually fixed the problem that was there. Or if there was an accident, you want to go in, inspect it, and make sure there was no critical damage, or if there is anything, you can address that before the signal falls. Hope I didn't blind anyone when I hit that button. So now you want to get prepared for doing the inspection process. Up here you have the FHWA. There's the guidelines for installing, inspection, for installation, inspection, maintenance, and repair of structural supports. This is primarily for your signs, lighting assets, signal assets. This was actually a key resource in designing and modeling the implementation that we're going to be going over today. But as part of that, it gives you a lot of different standards. It talks to you about what kind of standards you have for asset condition, maintaining those assets, using the right materials for those assets, all kinds of stuff.
The FHWA, did they sort of come up with those guidelines on the inspection on the previous page about the initial, interim, in-depth?
Yes.
Okay.
Yes. That actually came straight out of this manual with a little fluff of myself. So it also includes the asset inspection requirements, your FHWA defined elements, and that's actually what we've used for a lot of our inspection processes that we put together. So I want to get into that a little bit. The base elements. There's actually 17 base elements that FHWA has defined. I've listed the first 4 here because these are your critical ones, your foundation, your anchor rods, base plates, and tower, and they can come out with all kinds of different names. We've actually got a slightly different name in our system for that. And then it also allows you to develop custom elements that you want to test for, and that's where you have the S18 and any higher numbered elements. So that allows you to get in there and do a little bit more of, this is where my focus is, this is what I want to inspect for. So next we're going to talk about the setup process. So in our implementation, we have 3 basic core components. We have our inspection elements, our parent elements. We do a checklist of items. Those items do get tied back to the actual parent elements, and then we have checklist types. And we'll kind of, that seems a little vague right now, but I'll explain that a lot more detail on the next slide. We do have some other setups, such as priority and status. These are optional things that you can use. They're really not critical to the inspection process, but if you know something is way more important than something else, you can give it a high priority over a low priority. And then status is actually important because you want to mark your inspections as completed when they're done. Marking that as completed will affect the results because you don't want to consider anything in any results that aren't finished. Oop, I went backwards. So, in the implementation we're going to be covering today, these are the parent elements that we have defined. We have the foundations, anchor rods, base plates, and tower, like we talked about. But then we also have a MAC upper connection, MAC lower connection, mast arm, power and luminaires, and a winch and cable system. And you'll see each one of those has its individual structure numbers or element numbers right there. We do have the FHWA standard condition ratings in here as well. It's basically a score of 1 through 5 if it's applicable. And then let's look at this checklist type a little bit. So each one of these elements can have a number of different items that you want the inspector actually check for. So you can actually create, like I have, I'll tell you on the next slide actually. I have things like cracking or spalling or corrosion that I want to look at. You can tell it whether you want to have it a result type of yes, no, or if you saw the other one, satisfactory, unsatisfactory. This gives you a lot more flexibility into what you want to put together, how you want to answer these checklist items. Actually gives you a grand flexibility. So in this particular window, this is actually setting up the inspection. So on the left, we have our inspection types, inspection elements on the top right, and the checklist on the bottom right. Ooh, I keep going backwards. Now, taking a closer look at this, I want to highlight we have 3 separate inspection types in this system. In there, we have defined elements per the inspection type. So you can do any kind of number of things depending on how you want to inspect your assets. In this implementation, there is a different degree of things they want to look for a standard lighting unit versus high mast lighting. So that all gets defined separately in here. And then from there, I'm going to take, obviously I've been taking a closer look at signals. So with the signal pole structural inspections, foundations, anchor rods, base plates, tower, MAC upper and lower, mast arm, luminaires. So all that stuff gets looked at. And then we tie those, because you can rename those any way you want, depending on what you're on, back to the parent element. So now that you got it all set up, you're ready to go. So on to the process. So this window is the actual inspection request window. I'm going to go through each of these at a lot closer of a look. But on the left side, we have the actual header row of the inspection. On the right, we have the actual elements that are going to be inspected. And then on the bottom right, we have the checklist items. And you'll see each one is tied to whether it's foundation or something else. So this record will define what you see here, and then whatever you select here will define what you see down here. That's essentially how this window works. So taking a closer look at the inspection header. When someone wants an inspection to happen, you make a request. Throw a new record in this window. You can go ahead and you can define what's going on. Some of these things are going to be filled in by default because for this window there's only one signal inspection, so that's the one that goes in here. Status, priority, those just get defaulted to start off like that. But the next thing you want to do is you want to select your signal system. That'll define this is where I'm at. And then get a little more focused. This is the assembly, the pole assembly that I'm going to be inspecting. So those are the core details. And then if you want to, you can add some additional information like when I made the request to get this inspection done, when it's due, or if I just went out and did the inspection, you can just put the inspection date on there, right there. And please feel free to stop me at any time if you have questions. Yes, sir.
Who's doing the inspections? Do you have a separate inspection that's done for signaling components, those kind of things, from who's actually doing structural inspection of the mast arm?
There are in this implementation, it's for Minnesota. Minnesota has 3 different inspection types that they do. There's a functional inspection, an operational inspection, and a structural inspection. So the first 2 are going to be handled completely outside of this process, and this just focuses strictly on the structural.
We have a consultant, Keefe, that did this work for us. We'd like to do more of it in-house, but we're not sure if we have enough resources. So,
Yeah, we're doing this, we're building this staff part of that, and the components, and the big problem is the whole mast arm, the structural standpoint. Everything else is done by the signature.
All right. So we covered the inspection header. Now once that's set up, this is the closer look at the inspection elements. We already talked about those briefly earlier, so I'm not going to read them all over again. But you can see each one of those gets a condition rating defined, and then once, if you have anything special you want to add, each one of these records is enabled for comments to be added. So if you have anything additional you want to say, you can add that stuff here. And then let's take a closer look at the checklist. We pretty much have the same general set of information. We have for each of the inspection elements a list of checklist items that they're going to be looking at, the results that they fill in, and then if they have any additional comments that want to be put in here, you can put some additional things in here. I said something like see attached picture. So as far as attachments go, for this, for our core product, you would be able to add attachments to any record in the system. So you could do stuff to the checklist item, or you could do stuff to the actual elements or the inspection header. Now, personally, I would recommend you stick with the header and stick everything in one spot so you don't lose track of what you've got. And as far as Minnesota's implementation goes, that's exactly what they've done, because their actual inspection headers are integrated with a document management system to allow for that seamless transition. Yes, sir.
Promise not to be being like a kid in the class. Oh, are they doing this? Are they using FDC or a tablet, or are they doing this on paper when they go out to do these inspections?
We just went live a month ago. They have FDC, but I do not believe they haven't started. I know they haven't started using it yet. As far as the inspection process itself goes, I know that they've contracted this out in the past, so they do have the capability of doing that again. And if you do end up doing an inspection process on your own and you do want to contract it out, you can create standards and put those in place, and then use those to load data. Everything that I've shown you, I think I might have made this one up just to keep myself on the same signal system going from slide to slide. But there is a lot of converted data in the system. I'm not going to be able to see how many records from here, but tens of thousands of records got converted in to manage these inspections. And if you have something standard like that and you tell your contractors, this is how I need to get my data, you can just start loading that in as you get it back to them. And I think that might be an idea that Minnesota might run with. I don't know, Tom, Wade, or Trish, you might. Okay. I think they're still trying to get comfortable with the system before they start diving into the nitty-gritty with it. So I did talk a lot about signal inspections. I did want to bring this window up just so I didn't ignore it. This is the lighting inspection process. We're looking at one of them, the high mast lighting. So there's only 6 elements that they look at here. And I do want to highlight that they do use foundations, anchor rods, transformer, and base plates in the tower record, just like we did on the other inspection process. And then they're looking at power and luminaires and the winch and cable system, so if it has any of that stuff. So now they can do a different set of elements, a different set of checklist items to fill out that inspection record. And the actual other lighting inspection only has 4 elements that they're concerned with. They're not concerned with the other ones. I believe it's 4. So the next thing we want to look at, and this is going to get a little fun, is the results. And you'll see what I mean right here. So there's a lot of stuff. There's a lot of moving parts in the system. If you want to, the rest of it hasn't come in. I must have forgot to hit save. Okay, so let me define what this is. In the middle here, you have the basic setup items that we talked about. So you have inspection types, parent elements, your checklist items, and then rating information down here. So that's all set up. Over here, you have the actual inspection tables that we're using. But more importantly, what I want to talk about now is the results, which the whole right side is how the results get handled. So let me talk about these one at a time and just kind of keep going through here. You don't need to worry about reading that. The first view, these are all views up here, by the way. The first view takes all the inspection data that you've entered in the system, and it basically just compiles it together and says, okay, this is what I've got. It's just raw data. Moving on, and there's some additional pieces added, which I won't get into right now, but there's a reason why we couldn't just pull it directly from the table. So going from there to the second view, now what we've done is we've taken that raw data and we've aggregated it up to by asset and by date. So we added some additional information in there, and again, there's some other information that we're going to be using to do the next view as well. So the third view comes into play now. What that is that's for on signals, it's for the signal pole assemblies. So what it does is it gives you the latest inspection for the signal pole assemblies. You only have one record per assembly in that view, and anything that's older, all the history, it won't show up in that view anymore. You'll still be able to see it in the system, it just won't be in here. And then the fourth view, that actually aggregates it up one more level. Now it's going to the signal system. And if you remember from earlier, we have multiple signal pole assemblies in one signal system. From that point, we're going to jump from there down to here. We have some system jobs that we've set up that allow the system to aggregate that information and start plugging it in to the signal system inventory and for the pole assemblies. So now you're going to have your ratings for each of those assets added to the inventory table itself, saying this is my current rating, and that's what I need to know. The reason why that's important is because now we have these two items that we've skipped. This table here, setup asset defect. Everyone who's worked for AgileAssets for probably X amount of years knows what this table is, because it's a core table used by all the maintenance management modules that say this is my defect and this is a rating that I may have to basically trigger preventive maintenance work. That's where it all ends up going. And then from there, the latest defect survey comes into play, and it enables you to be able to use that asset defect to say, okay, if something falls below a certain rating, in this case I guess it would be above a certain rating since lower is better, it'll trigger preventive maintenance. So another way to look at this. Our results are available by inspection, and the inspection history is available to all the assets. It's available by the actual latest pole inspection, and that's what we're calling our current condition. And then we have it by system. And one thing I want to show you here is we have 4 signal pole assemblies. Only 3 of them got inspected, so the 4th one was immediately ignored. The worst signal system was this one right here with a rating of 1.2222. That became the structural condition of the signal system itself. So we're in this implementation, the decision was to use the worst rating, and that is the integrity of the system. Because that's what you really want to focus on. You want to focus on the problems. You don't want to focus on things that are looking great. So
Is the system an intersection or a network?
it is a intersection. So there'll be many systems on the network. I think 20,000 systems. There's a lot in Minnesota. There's always tomorrow. 26,000? Oh, 2,000, okay. I must have been thinking about lighting though.
Not for network, like 27.
So 1.222, that's great. So we're good. I mean, it's not great, but it's better than critical condition. So again, now we're going to take another look at this. All the table name or all the view names have changed, and the table names have changed. This is lighting as opposed to signals. Everything in the middle, the entire setup, is using all the same stuff. And then all the preventive maintenance and the system job stuff is using all the same stuff. So you can see, you can do a lot of different assets following this process, and it'll actually all fit in this core mold together. And then we have to have separate tables for the different type of assets. So you have your lighting inspection request and details down here. And then you actually have lighting related views to compile the data all together. So with that said, the other use we have for this is now we have a historical record of condition history. You want to know when you've done all your inspections. You want to be able to prove that you've done all the inspections that you need to be able to do, or that you need to do. It also enables you to be able to do preventive maintenance scheduling based on a condition score. And most importantly, you're now managing your consumer safety. You're not leaving these things going unchecked to potentially be a danger to the public. That is a danger to the public. That's not in America, by the way. I don't know where it is. So another good thing to know, if you don't want to go the preventive maintenance route, which I know Minnesota is not going that route, they're taking a little bit different of a turn. You can do work requests directly from your inspections. So if you know that you have defined problems, you can start creating work requests out of that, and then it defaults certain information, like what administrative unit you're in, what asset you're dealing with, what actual specific asset you're dealing with. That's asset type, by the way, over here. And then you can further define what activities need to be performed and sub-activities if you're using sub-activities, and then any other information that you have available on your work request form. So at this point, you can now fire off not just one, but as many work requests as you want to define the deficiencies, or to address the deficiencies with that asset. Make sense? Anyone have any additional questions? All right. So let's take a look at the actual environment. Maybe I can just click that and it'll open right up. Yes, sir.
Do you guys track moving signal points around?
Yes, it's that's the 26,000 components she was talking about. That's Tricia up there was talking about.
For example, what they talk about, the components inside of the signal cabinet. You got a board that's in the cabinet. If it goes bad, they take it off, and they call it bad shop, and go to the shop, get fixed, and you just move it. Once it gets fixed, it gets installed in another cabinet. We're tracking all of that, and we're the whole history for that. So they do that with the number of the components. The signal system.
Is there a signal map?
Signal level.
Signal map. Do you have a signal map when the components come in, they get tested, order them, test them, determine whether the batch is acceptable?
Yes, they do. It's all under the umbrella of our electrical services unit. So they, you have the lab technician, you got the electrical technicians, and it's all under our traffic, the umbrella of traffic. So, but yeah, we do have our own lab for lab regular repairs.
Are you managing that stuff through this system? Just inspections?
The intent is that.
Work requests to capture these things? Can find this better?
Yes, yes, which is, we had a visit out to the services unit last week. This was typically about how they're making, how they get a work request, how they generate work orders, how they pick the work request when they have, when items that are being bad, they have to be replaced, and, pieces come in, and go to where they're going to, they take one to this area, they're going to this, the holding shelf, or bad shelf, good shelf, it's scrapped out, that's all, we want to track the whole history of the components that they're with. Warranty and cost, and to see if you have a particular, you might have one particular or a particular a batch of components that are giving you the same type of problem, but they're scattered throughout this department. And if you don't necessarily see that, and now we've got a centralized system that you can see that and say, geez, it's all this one particular controller. It's giving us the same, we're doing the same type of repairs constantly. So.
Before I jump into this, do you have any additional questions? We have 10 minutes left, and this may be cutting it close. Or I could just zoom through it and just dazzle you with my skills. The signals module is Signal and ITS Manager. It's a relatively new module, so there is some work that needs to be done to actually get Agile Core, refined. So it will need some configuration. And the inspection process itself does get configured around the assets that you have. And I don't want to say anything more from there because I might, I've got my boss and my boss's boss rather. Okay, so this is the inspection request window. Let's try to go from this angle. So the first thing you can do, you can add a new record, you can copy from an existing record. And I just want to highlight, when you add a new record, that's what you get. You get that header record. So this window is built with the glider bars, so you're not going to be able to do the maximize, minimize. I don't know if anyone knew the difference between those. But when you have these bars in here, that becomes useless. So the administrative unit is filled out, and that is unchangeable. That's a standard within this implementation. So the first thing I'm going to do is I'm going to select the inspection type that we didn't cover yet, the lighting unit. I'm going to leave the status is pending, priority is medium. I'm going to go ahead and select a system. Now I know I wanted to do signals. Minnesota's wondering why my assets don't look like they're supposed to look, because all of them have names like this on them, and you'll see the system didn't get that. Alright, so I've got my system selected, I've got my lighting unit selected. Now when I'm ready to do it, I can and I can put in additional date information if I want to, but I'm not going to do that right now. I'm just going to kind of cut a few corners. So the next thing I want to do is I want to add my inspection elements. And in this particular case, we just did one blank insert and we added our foundations, our anchor rods, the base plates, and the pole tower. One or the other. So I honestly don't know why you're not inspecting the power at this point, but maybe you have reasons for that. But let's go ahead and we can come in here, select each one of these inspection elements, and that's when we can start adding our checklist items. And there's 9 rows on this one we can go through. Then I have to ask, why are you doing it on the high mast? Yeah, there is. I'm sure there's reasons out there. So in here again, we can go ahead and we can start filling in our results. It's not displaced. It's not eroded. It's got no efflorescence to it. And I don't even know what that means either. I know you explained it to me at one point. So at this point, I can keep going. I can fill in all the results for my checklist items. Or, I mean, that's really optional. You can come up here and you can fill in your condition ratings. These are the core elements that are actually going to be defining the condition score. So I'm going to say this one has good anchor rods, a fair foundation, but it's got poor base plates and a poor tower. So it comes into play, the next question that you may have is, okay, so what does all this mean? Each one of these gets calculated in a certain way, and you may have caught that when I was going through the slides, how the scores get defined. But they get defined by the parent element. Then you can further, and that's if you want to go global, or you can standardize that one and you can do it by your actual inspection element. So now you can say each one of these inspections has a different way. Maybe my lighting inspection, my base lighting unit structural inspection, is more important to have the foundations looked at as opposed to the, I'm going to say, power and luminaires. So maybe the other one is higher on the other one. And I'll show you a look at that as well. So let me go ahead and let me save this. And let me just run and I need to complete this. So I'm going to go ahead and complete it. And now I'm going to run the update. And for the common users, they don't need to do this. A system job can take care of this. So don't worry too much about that part. It may look like Greek. Okay. So what I have in here is I have a calculated condition rating of 3. So based on my 1, my 3, and my 2 4s, it all got translated into an overall condition of 3 based on the weights of my scores. And in this particular implementation, we weighted our parent elements as opposed to getting down into each individual inspection and weighting those items. So this is, Trish, this is the question you were asking me earlier today. How is this thing scored? You have your weights right here. This is a magnitude of importance. So I'm going to look at this. Yeah, let me walk over there. I can barely see that. Check. Okay. So in foundations, this is 3 for those of you in the back that may not be able to see this. That means it's 3 times more important than a 1. Down here, power and luminaires in the winch and cable system, those are set to 1. Anchor rods, transformer base plates, the tower, those are 5s. And then for signal systems, that's the only one that has the MAC connections. Those are 5s as well. And then mast arm is set to 3, and then, as I mentioned earlier, the other ones are set to 1. So that is the current setup of how your how the elements are rated, how they're weighted, rather. And so, Trish, if you wanted to have another way to do this, you can come in here, you can modify them accordingly, and set them to what you need, or you can, standardize all these to maybe a weight of 1, and then go to your individual inspections and define your weights there. That way you can do your lighting unit, your high mast lighting, and you can do your signal inspections very specifically. This is how I want that to be scored. Make sense? All right. Being very, I don't need that anymore. Knowing how much time we have, I better wrap up. So let me go ahead and get out of this. And there you have it.
Thank you, Eric.
Thank you.